Okay, so let's solve this problem. After reading this problem, you can see we're trying to find a probability, but actually, a probability is just counting the number. And how do we count it? Okay, the next thing we realize is this 10 is kind of arbitrary. We can just change it to n. And the next thing to realize is that this is probably a recurrence relation. So let's an be the number of arrangements such that people satisfies. Okay, so we want to find a recurrence relation for that. Well, what is an plus 1? Well, firstly, you can take an, of course, and let the last person have the same color with the second last, but obviously that is not it. So what if, for example, the first three was RRG? That was not counted in AN, but then if we let the fourth person be G, then this works as AN plus 1. Okay, also notice that here, RRG, for RRG, these two people have a neighbor, but this one doesn't. So G doesn't have a neighbor that satisfies. So we also have to let Bn be the number of arrangements such that only the first n minus 1 people satisfies. So first n minus 1 people. Now then we have Bn here. But what is Bn plus 1? Well, it's just, well, 2an, because if an ends in, for example, red, you can let the next one be green or blue, and we're done. But if it started with Bn, then it doesn't work. So we have the recurrence relation. We can just make this equal to an plus an minus 1, 2an minus 1, and it's a standard recurrence relation. Now we have A2. Well, there's 3 choices, and A3, after a bit of counting, is also 3. So, an alternative way to get this is just by noting B2 equals 0. 0. B2 is 0. Okay. So, now that we have the first two values, we can calculate a 10. And if I'm not mistaken, it should turn out to be 513. And dividing that by the total number. Okay, what is the total number? 3 to the 10. Dividing by that results in the final answer of 17, which is 530 divided by 27, over 3 to the 7th, which is 19 here, and over 2187, and that right there is our answer, and we are done.